Hello class, this is CSE-4410, sections 1 and 2, chapter 5. I am no longer be going by week numbers anymore, I'm just gonna go by chapter numbers from now on. Because part of the reason why is I want this material to be agnostic of week numbers, and maybe eventually agnostic of time itself. Unless I have to redo the video because of updates. Anyway, we are going to work on one of two 2D games, and the first one is we're going to make a memory game. So the goal is simple. We have cards where we want to reveal what they are. So really this card should be face down. So this is actually a business card for something called Card Kingdom. This is a promo card that also doubles as a fairy token. Our goal is to reveal 2 cards at a time. If they match, then they are removed from play. If they do not match, they go back to being face down. Our goal is to reveal all the cards. Match every card with its corresponding pair, and that is how we win the game. I realize now I have some Pokemon cards that I could have used for demonstration purposes. Because... okay, let's just go with this Pokemon card. So, if you can imagine a Pokemon card like this, we reveal it, flip it over, it's a Smoliv. If there's another Smoliv card on the field, we try to find it. If you can't find it, and we reveal some other cards, such as this, they don't match, they go back to face down. Okay, so we would begin this by creating a new project. We want to select the 2D template. We name our project. We give an appropriate name for our project. Say 2D memory game, and then we click create project. I have already created this project ahead of time, and that's simply because I want this thing to load in time to start the project itself. So let's begin. One thing you'll need to do is you'll need some assets for this. So we need 7 assets in total. And that is going to be these 7 things here. So we have a card back, 2 for different card fronts, a background for a tabletop, and a reset button. You can get these assets from just consulting the corresponding PDF containing, well, a link to the relevant GitHub page, because the author of the textbook has a corresponding GitHub repo containing all of the completed projects for all of the projects described in the book. We just need the game assets. So if you go to that GitHub link, you'll find something, you might find a page like this. All you gotta do is download all 7 of these .png files. Do not download the png.meta files. Those are different. They are for Unity's own use. What's a meta file for? It's for Unity to keep track of what this asset is being used for. So you don't need the meta files, you only need the PNG files. So there are 7 of them you need to download. Once you have them downloaded, you can, depending on where you have them downloaded, they're probably going to be in your downloads folder. All you got to do is, once they're downloaded, drag and drop them into our project view, and now we have all of our assets. Now, there are a few key differences between a 3D game and a 2D game that I like to go over. Chief among which is how images are treated. In a 3D game, images like this are treated as textures. So if you drag and drop them from the project view to the scene view, they're probably, if you are to hover it over a 3D object, it's going to try to apply it as though it's a material. In a 2D game, if we try to drag and drop, say, this tabletop, well, now it's actually a sprite. It's called a sprite. So think of a sprite as a thing that holds an image. And that thing that holds an image is in the sprite renderer component in the field called sprite. One thing to know about Unity is this. It was originally a 3D game engine with 2D functionality added to it later on. So that's why in the inspector, you're still gonna work with XYZ values. You're still gonna have you're gonna still have 3D coordinates. So here it's X, Y, and we can't escape the Z. One thing to know about how the axes in Unity work is think of the X and Y axes. Think of the X-axis as going left and right. Think of the Y-axis as going up and down. Think of the Z-axis as going forward and backward. So forward would be like going... To go forward in 3D space in this context is to move into the monitor. And to move backwards is to move out of it. So, one thing that I already have done was size this camera so that it fits to the size of our sprite here. So this sprite, if you look at it in here, if I look at it here, it is 1024 by 768 pixels. And by default, unless we really need to, we should not change this pixel per units away from anything other than the default of 100 pixels per unit. So with that in mind, that means this image here is about 10 by 8 units large. Technically it's 1.024 by 7.68 units. In Unity, in a 3D game, 1 unit corresponded to 1 meter. In a 2D game, 1 unit corresponds to 100 pixels. So by default, this camera was actually set to a size of, not 6, 5. So that means on the shorter measurement, which is for us the height, the measurement for the size of our camera was 5 units. Which means for this image to fit, it really should be a 1000 by 1000, rather a 1000 by, it should be a 1000 pixel tall image for this to fit snugly with the camera. But the reason why it is 1024 by 768 is because for a while that used to be the common resolution for computer monitors. These days it's what, 1366 by 768 at least 1366 by 768. The most common most common screen resolution is what? Let me just did a cursory search on this on Google search. Common screen resolutions include what? 1366 by 768, 1600 by 900, 1920 by 1080, 2560 by 1440. There are some other ones that follow a different aspect ratio, like 1920 by 1200. That's not very common these days. There's also 2560 by 1440, 3840 by 2160, the coveted 4K resolution, not because it's like 4 1080p's stitched together into one big block, but rather it is an approximation of 4000 pixels, which to some people it isn't even true 4K. 4K would be 4096 pixels wide for some people. But that's the naming scheme we're stuck with. So let's just roll with what we got. And if you think about it, this sprite might be a little bit too small, but it is this specific ratio, so that way if you're to play this game on a 1024 by 768 pixel screen, then every pixel on this image will map neatly to 1 pixel on the screen itself. That's called being pixel perfect. So it means if you want a high resolution version of this game, you're gonna need to find or rescale the existing sprite. Which we could do, but let's just stick with the default size for now. It might be a bit small, but let's roll with it. Anyway, if you want to scale down this camera size to fit, then you want it to be 3.84 size. And that is because of this calculation. So it was 768 pixels tall. We need to divide that by 2 because it's actually going from the center. And remember that each unit in Unity by default is, okay, for an image, the default measurement the default measurement is 100 pixels per unit. So I'm going to divide by 100. So that is 768 divided by 2 divided by 100. I press enter, and it calculates the whole thing to 3.84. One other thing we also have to do is, also by default, the camera has this set to a blue background, so something like this. Maybe a little bit darker than that. Something like this. So if we are to view this in the game view right now, we get these blue bars, but I'm going to set it to black, so now we have these black bars, and it looks like we're watching a YouTube video from like the late 2000s, where YouTube didn't even support widescreen video yet. And now YouTube can support ultra-wide video formats, so like 2560 by 1080. And maybe some of you have a screen resolution like that. So that's actually its own design consideration in and of itself. How big of a screen is your end user using? If it were to me, if I had to hazard a guess, aim for 1080p, maybe 720p as your minimum screen resolution. Okay, so now we have our tabletop ready. Let's begin with adding a card. So I'm just going to take one of these cards. I'll just move it here. I'm going to set its position to what? Let's go with -3, 1.5, 0. And let's also add a card back. So because these two are... Hey, wait a minute. I'm supposed to have... So what's supposed to happen is this. The card front and card back are two separate things. The card front and the card back are two separate things, and one must overlay on top of the other. And yet, it has to be such that the card front is overlaid on top of the card back. So the back hides the separate front. So what went wrong here? Well, it's because of how these things are layered. So even though this is a 2D game, we still can use the still use the third axis, the z-axis, for our own use. And that is to layer our sprites in such a way that some sprites will be in front of others. So if I'm to change this, and I can change this to a 3D view, if I'm to do that right now, then if we look at it here, we'll see that all three sprites are just sitting on top of one another, and that is not good. It means that the card back might not necessarily be in front of the card front unless we move it a little bit in front like that. Similarly, we can move the background image here a little bit more forward. So remember, forward in a Unity game is moving towards the monitor, moving into the screen. Moving back is moving towards the camera, out of the screen. So let's move this a little bit like that. We can leave the card front at z value 0, and this what I'll just do is I'll copy position, paste position. So now they're on top of one another again, but I can just move the card back a little bit in front like that, say a -0.1 like that. So that way the two sprites aren't, they're gonna have the card is gonna have the front behind the back. And setting these values as so guarantees that the front will always be behind the back. Alright, now we have a card. One other thing we need to do is to make this card back a child object of the front. So that way I can just click on the card front, and if I move them, they move together. And that's the thing about making nested game objects. If you move the parent, all of its children move with it. So those are the things you have to do. Yeah. One other thing. Because our cards must respond to being clicked on, if I play this game right now, well, obviously nothing's gonna happen because there's nothing coded so far. All we got so far are just sprites. So now is the time that we create a script. Let's call it memory card. And in a project like this, it's perhaps a really good idea, and at this point it's strongly recommended, if not required, to organize all of your assets by what type they are. So scenes go in their own folder, sprites go in their own folder, scripts go in their own folder. What I'm just going to do for now is I am going to move all my sprites into their own folder. So create folder, I'm going to call that folder sprites. I am going to leave the scripts outside for now. But again, it's a good idea to have sprites in their own folder, as with scripts in their own folder as well, so they're not all mixed up. Okay, so now we have a memory card script. I am going to drag and drop this onto the crescent symbol sprite. Now, one thing to note about a sprite is when I drag and drop these sprites, they aren't the images themselves. Rather, what Unity did in the background is it created its own sprite object and set that sprite object's sprite renderer to be the sprite that we were dragging and dropping into the scene. So these sprites, think of them as a thing that holds a picture, and that picture is, well, in our case, the crescent symbol. But there is nothing stopping us from changing one of these images to be something else. So check this out. I have the card back selected, and I'm going to drag and drop the start button into the sprite field of the sprite renderer. Now I have a start button on top of my crescent card. That's not what we want, but it's not too far from what we're actually going to do later. Because when we populate this grid, when we populate this tabletop with a grid of cards, we want to randomize the cards that we have. So it's good to know that, hey, these are sprites. They're things that hold images. We can change the image as we need to. Okay, so now we have some code here. Now, for this card to respond to the player clicking on it with the cursor, we need to go to the card front, the crescent symbol. But before we get to that, I'm just gonna rename these things so that they have better names. So, just to make them more consistent with the name of the camera, so tabletop, crescent symbol, I'm just gonna call that card front. The card back, I'll just call that card back. So, this card front, which currently has our crescent symbol, I am going to add a component to it called Box Collider 2D. Now, in our scripts, in the memory card script, I am going to open that, and then I'm going to add a little bit of code. Not a lot, but enough to know that our clicky-clickies are being registered by the game itself. So I'm going to open up for me, it's Visual Studio. I'm just going to add one method to this, and that is if this can respond. Yes, there we go. I'm going to type in public void on mouse down. No parameters being passed in. So this is a method that comes with Unity itself. If you add this in, then the object is going to respond to being clicked on by the user, given that we have a box collider on it. Okay, now all we gotta do is write in debug.log, and then I'm just gonna say something like, this card has been clicked. There we go. So that card now has code where if we are to play the game and click the card, we're gonna see a message that says, this card has been clicked. And now I can spam the console. Okay, so now our card can be clicked on, but nothing's happening. Let's change that up so it does something more interesting. So now that we know that this on mouse down is working, let's change the code a lot. So, what's good practice is to remove any unnecessary methods that you don't use here. That when you create a new script in Unity, it's going to have a start and update method by default. You can just take those out if you don't need them, because one good practice that's often spoken about in Unity programming is to remove any instances of a update method that is empty. That way, it's less load for your for the CPU when you run this game. With such a small game, it doesn't really matter all that much, but with a large game, it can add up. Okay, so I'm gonna do two things. First, I'm going to create a private field called card back. So I'm just gonna say, now we don't want this field to be edited by anything except for ourselves. So I'm just gonna add the serialized field tag to it. Serialized field, and then game object card back. So this is going to be, now the card front has a game object attached to it, that's the card back. The entire script is attached to the card front, so we need to attach the card back to that script. We'll do that in a bit, but let's replace this debug code with a different line of code where if we click on the card, then the card back is going to be hidden. We should say card back.set active false. If I can spell. Save that. Now, if I click on the card should reveal the front. Oops! It did not work. Unassigned reference exception. That means we forgot we had a field somewhere that we didn't assign anything to. If we go back to our card front here, we look into the memory card script here, and then we have a card back field that we did not assign anything to. It's this card back. So in the inspector, we have a card back here, but we want the card front. So in the hierarchy, I'm just going to drag and drop the card back from the hierarchy into the field in the inspector for the script that is attached to the card front. So let's try that again. Click, revealed. Okay. So now we have the basic functionality of a single card. Well, we don't have any code needed that unhides the... We don't have any code that unhides the front, but we can get to that in a bit. So it's coming together quite nicely, except we only have one card. Well, I'll tell you right now, this. Once we have a card, once we have programmed one card, we've basically programmed all of them. So there is a method in here. There's a method in Unity where we can basically clone an existing game object. That's called that is the instantiate method. So we can instantiate copies of the same game object. What we can then do later on is to, in code, we can change the card fronts of each card that we've made. So that way, every time we play the game, it'll be a different card each time. Let's get to work with the part where we have that card front being changed for something else. So in the slides that I made for this accompanying video, I talked about how we can change the sprite in code. So maybe let's do that real quick. I'm going to create another serialized field, sprite card front. And then I'm gonna put the start method back in. So private, I'll just say private void start, and I'm gonna say get component. Remember what I said about get component? It's gonna be your best friend. It's gonna find an instance of a sprite renderer, and then we're gonna do stuff with it. Say sprite, because that's the field that holds the sprite for the image, equals card front. So with that code, we're not quite done yet, because now we have a card front field in our memory card script here. All I gotta do is go back to my sprites folder. I can pick out some other sprites, say this one. And if I play the game now, what should happen is the card front is going to have its sprite changed on the start of the game, and if I click it, it's the heart instead of the crescent. So now, whenever we play this game, we initially had a crescent for our sprite. Now it's a heart. We can go one step further with this, and instead of just replacing one sprite for another, what we can do instead is have it like this. We randomly pick which sprite to apply. So that's our next step, actually. So let's go back to our memory card script, and we're gonna have to undo some of our changes. Well, not all of them, but now we need to do a few things. Remember in the other game where we had the concept of a scene controller? In the first-person shooter, the scene controller's job was to spawn an enemy if the current enemy was ever killed. Now we need to expand our idea of a scene controller. For here, it's going to be the one thing in our game that creates and places down all of the cards. It's eventually also going to keep track of the score. So that's what we need a scene controller for. So the concept of a scene controller is we have some game object that's running in the background that can keep track of various things about our game. Where is the character in their current objective so far? Is the character, what's your high score? For example. So, before we even add any more code to our memory card script, what I'm going to do is I'm going to create an empty game object, and I'm going to call it our scene controller. There we go. For this object, I'm just going to set its position to be 000. I am now going to create a brand new script. I'm going to call that scene controller. And then I'm going to drag and drop the scene controller script onto the scene controller game object. Now, let's go back to our memory card script and rewrite all this code that we just added. So, first things first, we are no longer gonna be changing sprites in the memory card. Rather, the memory card is going to have its card sprite set by the scene controller. So, for this to work, we need this thing to have a reference to the scene controller, so I'm gonna say that. So, now the scene controller is gonna be referenced by our memory card. Now I'm gonna add a few other things here. I'm going to add a private field called ID. I'm going to add in what's called, in C++, for example, you will have probably learned about the idea of a setter and getter. In C#, there is something called a property. Think of it as a variable that has like automatically built-in setters and getters. So I'm going to create a public property called ID. But not like that, because that would be basically a field. So I'm going to add curly brackets after that, and I'm going to say get, and then within curly brackets, I'm going to say return underscore ID. So this is going to return our private field from earlier. So that's our property. It's going to basically fulfill the role of a getter in, say, C++. So it's basically as though it's like get ID. It's as though we're calling a function called getID, but instead of having it be a separate method in C#, we're just going to make it a property. Now, I need one other thing, and I'm just going to cut that line so I can paste it back in later. I'm going to type in a function called setCard, public void set, no, not set function, set card. So I'm gonna say it's going to take in two things. The first one is a numeric ID for our card and a sprite. And then I can just type in, I can just copy paste that get component line from before, but instead of card front, it's going to be the name of this parameter. So there we go. Oh yeah, one more thing. I'm gonna say underscore ID, that's our private field, equals ID, the ID that we passed in. So when we compare cards with one another, we are not comparing their sprites. Rather, every sprite is going to have associated with it a unique ID. Instead of comparing the sprites, we're going to compare their IDs. If they match, then we have a match. And if they have a match, then that means the two cards match. Alright? We're getting there. So let's go to our scene controller now and open up that script. So I'm just going to clear out I'm going to remove the update method because I don't really need that right now. But I will need the start method because I'm going to fill it with some code that initializes our one single card. So here's what we do. I'm going to need two fields for this. Serialized field, and it's going to be a memory card. So this scene controller is set up so that we must have one card on the playing field already. So this scene controller needs a reference to the card that we already made. But the card that we made also needs a reference to the scene controller. There's a much cleaner way to do this, but I'm not gonna get into it right now. I will say that it's something related to what's called an event system. So let's just focus on getting this to work for now. I'm gonna also add a private array of sprites. So serialize field, and then I'm going to say sprite with square brackets after that, images. In the start method, I'm going to say int id equals random dot range 0 to images dot length. And then one line after that, I'm going to say original card dot set card ID passed in, followed by images ID after that. So what does this code say? Basically, given an array of sprites, we are going to pick out a random sprite from that. We are going to use a random number generator to create our ID for that, and to use that to reference our sprite that we want. And then we pass in both into the set card method of our original card. So in here, the scene controller is going to require a reference to our single card that we've made so far. So the scene controller, we'll just drag and drop our card front object into here, and here are our images. It's empty right now, but we can just fill that in. I'm going to type in 4, and in our array here, I'll just drag and drop each of these 4 sprites into these slots. So now we have a whole array containing each of our sprites. Now, the elements here are 0, 1, 2, 3. That means they're gonna have basically those IDs applied to it. And the beauty about this controller is that this is expandable. So if I double click that, I have my system set up so that it can open up paint.net. So if you want paint.net, you're gonna have to do a little bit of searching because you can't really type in paint.net without it having be mistaken for a website like .net domain name or something like that. So look up paint.net. This is specifically for Windows. What I'm going to do for now is I'm going to create a brand new card. Now this is something that we don't need to do, but I'm gonna do this for demonstration purposes. I am going to create a brand new card type. Fill that in. Maybe you want something yellow instead, because maybe that one gave off communism vibes. Okay, let's go with the yellow star, because, I don't know, for some reason stars are yellow in the night sky. Even though they're not. So, let's do that. I'm gonna save this image as star symbol. But why stop there? We could add in another card type. Say, let's erase that, and instead of a red star, let's go with, say, no, instead of yellow star, let's go with, say, a red triangle. So I'm gonna save as. Now I'm doing this just for demonstration purposes. So now we have 2 more shapes that we could add to our game. In the scene controller, all we gotta do is change the size from 4 to 6 because we added 2 new shapes. I'll just drag and drop these 2 new shapes into these slots here. Save, run. And now there should be a 1 in 6 chance of getting the star and a 1 in 6 chance of getting the triangle. We got the diamond out of that. Let's try again. We got the crescent. Let's try again. Basically what this is showing is, yes, this scene controller can randomize our sprites, but at the same time, there's nothing stopping us from only having 4 cards. So if you wanted to add new cards, we can. And if you add them, then it's just gonna be a simple matter of adding them to the scene controller And right now I'm just seeing whether we can get those new sprites. So, now, either something is wrong or I'm just getting really unlucky. There we go! So now we have shown that this code is expandable. Because now we have the reds. We have the red triangle. Can we get the yellow star, though? No. I could just be getting unlucky with this. Then again, have we even seen the square yet? Okay, there's the square, but we haven't seen the star yet. Let's just call it good here. So, with that, we've shown that we can basically change the sprite for our card when the game starts. But we still only have one card. What are you doing about that? Okay, let's get to work on that. So, I'm just gonna set this back to 4 because this game was, how it's coded was originally meant for 4 cards, but to have it properly support more than 4 card types, we're gonna have to deviate from the book from that. But for now, let's just stick with what the book has. Work with that for now. Okay, now we want to create not one card, but a whole grid of cards. So in our scene controller, let's edit that. Rather, not this, but rather the script itself. So I'm just gonna open up our scene controller. Here we go. So now we need to add in a few public values. So public const int grid rows equals 2. Public const int grid rows equals 4. Public const float offset x equals 2f. Public, this should be columns, my mistake. Public const float offset y equals 2.5f. So what these values are is, well, the number of rows and columns we have, and the spacing of the cards between them relative to each card's center. Okay, so that's step 1. Step 2 is to flesh out our start method a lot more, so it's not just one card being set, it's all of them. What is all of them? All 8 cards, because our grid is set up to have a 2x4 grid of cards, that's 8 cards, so here we're gonna do it like this. First, I need to keep track of the starting position, because wherever our original card is going to be basically the starting point for our whole grid. So it's gonna basically copy this card, place it here, 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 and then do the same here, 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 here. So we need to record that, we need to keep a record of that starting position. So we're gonna need a vector tree start position, start POS. There are like 2 different definitions of POS. I'm just gonna then, on the right hand side of this equal sign, I'm gonna say original card dot transform dot position. Exactly what I needed. And now I'm gonna create a doubly nested for loop where it's going to create our grid 1 row at a time, and then it's going to create the 1 row by, it's gonna create 1 row where the number of cards in that row is the number of columns, and then it's going to repeat the same process for the next row and the next row. There's only 2 rows, but we can expand it if we need to. So we're going to create our doubly nested for loop as such. For int I equals 0, I is less than grid columns, I plus plus, for int j equals 0, j is less than grid rows, j plus plus. And then memory card card, because this is going to be the card that we make. So in this code, we are going to create a brand new card each time, and then we're going to give that card a random card front and a corresponding ID, and then we're going to place it somewhere on our grid. Thing is, there is a special case, and that is the card that we started with, because there's already one card. So for this whole game, we need to create 8 cards, but we already have one. So we really need to make 8 cards minus the one we already had. And that is our special case, so that's going to happen if I and j are both 0. So if I equals 0 and j equals 0, then we're going to say card equals original card. Else, we're just going to say card equals. And this is how we duplicate our one card. Instantiate. And we pass in the original card. And we're gonna set that as memory card. The thing here, it might say that this cast is redundant, but I'm gonna leave it there anyway, just in case. Then I'm gonna say int id equals random dot. I already had it here, so I'll just copy that, paste it here. So int id equals random dot range, and it's going to pick a random number from 0 inclusive to images.length exclusive. So it's gonna pick a random number, and the options are 0, 1, 2, and 3, given that we only have 4 card types. Then I'm gonna say card.setCard, because we have that setCard method. I'll just copy and paste it from here. So copy, paste. So we're going to call the setCard method that's on our card. We're going to pass it the ID, and then we're going to pass it the corresponding sprite for that ID. Now I need to give it a position. Float, position x equals. And I'm going to do some math here. Offset x times I, and then plus start position dot x float position y equals negative offset y times j plus start position dot y. And then I'm gonna say card dot transform dot position equals new vector 3 whose x, y, and z values are position x, position y, and the z value of our start position. So pause x, pause y, and then start position dot z. And there we go. So now we have this card, now we have this code in our scene controller, and what it's going to do is it's going to populate the whole grid for us. So I press play. We're going to know whether it worked or not. It worked! And now, we can click on each card, and we can reveal each card. And the thing is, this is randomized, so now, if we play it again, the cards are different now. But do you see a problem here? Do you see it? We made it so the card fronts are randomized, but they might be randomized a little bit too well. Because you see how there are 3 crescents and only 1 heart? This means this game is unbeatable. This game sucks! So, the problem is we made our random number generator a little bit too random. Let me say that again. We made our random number generator a bit random. So it's going to randomize our cards, but the rule is there must be 2 of any one unique card. So that way, if you have a card and another card, they must always match. Basically, every card must come in pairs. So let's make this thing not random, but smart. A bit of a pun here. Random? No, let's be smart. So here's the concept of how we're gonna do it. Here's the concept of behind that. So I'll just draw it out because I have paint.net open up here already. I'm gonna create a array of IDs, something like this. And it's going to be an array. I'm gonna say 0, 0, 1, 1, 2, 2, 3, 3. And then I'm gonna run that through a shuffling algorithm. So, once we have this array of IDs, we're probably gonna have some randomized array that could look like this. Say 3, 2, 2, 1, 0, 2, 3, 0. So first we have to write this array, and then we have to write the shuffling algorithm that scrambles all of these values. And let's not be random here because I made the mistake of putting 3 twos, so really it should be like that, where every instance of a unique ID occurs twice. In other words, every card should have a matching pair. Every card comes in pairs. So let's not be random, let's be smart. 3, 1, 2, 1, 0, 2, 3, 0. Like that. I'm gonna pause the recording and then we'll get back to that in a bit. So, remember how I said that one thing that we can do with a 2D game is take advantage of the z-axis that we don't really use? Well, this is why. You notice how we have 2 cards revealed even though I didn't even do anything yet? Let's restart that. I am touching nothing on the keyboard and mouse, and yet 3 of the cards are automatically revealed for us. So, and it gets worse. Some of the cards just flat out disappeared, and that is because if we forget to offset the z-axes, the z-values for each of these cards, then they might layer in weird ways, and we get either cards disappearing or cards revealing themselves too prematurely, or cards that are just flat out gone, even though they're there in the inspector, even though in the hierarchy it says it's there. So this is what I wanted to emphasize about using the z values for offsetting things. So again, I'm just gonna move this a little bit forward, and then I'm gonna move the card front can stay at z position 0. The tabletop must be pushed a little bit forward, say like that, 0.49. That's good. And the card back must be moved a little bit in front. There is another way where we can do this, and it's called order in layer. It does the same thing as setting these things in the setting these layering orders in using the z-axis. It does the same thing. It's just a different way of doing the same thing. Just that there is a lot more options if we want to go with the options presented to us in the sprite renderer. It's just that for getting this simple, we can probably just stick with the z-axis. Okay, so with that in mind, again, our goal is to make our random number generator smart rather than random, where we could have cases where we have unmatching cards. So let's just go back to our scene controller, and in here I'm going to create that array of numbers. Int square bracket numbers. So this is going to represent our deck. It's going to represent a deck, and then we're just going to... Basically, this represents our deck in code. So now I can just say 0, 0, 1, 1, 2, 2, 3, 3. So how it is written, and I must point this out, how we're writing it right now is not scalable. We're going to have to do some more modifications to this code if we want our code to support these two new cards that we just made earlier. But for now, let's stick with this. We can cycle back to that later. So numbers equals shuffle array, and then I'm going to pass in numbers. Now, we don't have that shuffling algorithm yet. But for now, I'm just going to comment this out. So instead of picking out a random ID, I'm just going to say int index equals j times grid columns plus I. And then I'm going to say int ID equals numbers index. So what's happening is I am translating these two I and j values into an index that references one of these values here. So once it's randomized, I can just pick that out, and that's going to be my ID for our card. So after that, all the code's going to be otherwise the same. Except for the fact that we don't have a shuffle array. Let's get to that. Now, I'm not going to get too deep into the details, but this is what's called the Canute shuffling algorithm, or the Fisher-Yates shuffling algorithm. So the code is here. Let's look at it much closely. So we create a new array. We can create a copy of our array, and then we're just gonna, for each element in the array, we're gonna swap it with some random element that's also in an array. So let's copy that code. Private int square brackets shuffle array, and I'm gonna pass in a single parameter that is our int array of numbers, and then I'm just gonna type in int square bracket new array equals numbers.clone as integer array. And then I'm gonna add a for loop. Maybe I should just zoom in, because there we go. There we go. So now that it's a little bit larger, it's probably easier to see, because one thing that I do with all my video recordings is I record at a 4K resolution, but it's downscaled to 1440p. I used to do this at like 60 FPS, but I think I've long since set that to 30 because frame rate issues. It's also to reduce file size, because these recordings are just huge. Anyway, for int I equals 0, I is less than new array.length I plus plus, and then I'm gonna type in int temp equals new array I int rand equals random.range I new array.length, and then I'm gonna say new array I equals new array rand new array rand equals 10. So what it's going to do is it's going to iterate through the array and swap two random elements in the array. And then I can return that array. So, with that, if I play that game now, what should happen is this. I click, 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 and every card has a matching card. Every card comes in pairs. So now everything's starting to work. Now, we need to go back to our original rules for our game, and that is we can only reveal two cards at a time. If they match, they're removed from play. If they don't match, they're rotated so that they flip back down. Let's get to that code now. So for that, we are gonna have to go back to our scene controller. So let's open up the code for our scene controller once again. We need to keep track of the two cards that we are revealing. So we need a first card and a second card. So I'm gonna say private memory card first revealed equals. I don't even need an equals. So I'm gonna say private memory card first revealed, and then I'm just gonna copy this code, paste it here, and I'm gonna say second revealed. I'm also gonna add in a property that says can reveal. So the rule is this: we are allowed to reveal up to 2 cards. If that second revealed, so these are gonna be references to the cards that we have revealed. If first revealed is, okay, so we know that we can reveal 2 cards if both first revealed and second revealed are both null. Oh, actually, no. Since there's an order, what matters more is this: whether second revealed does not equal null. So, if we reveal 1 card, then we can still reveal a card. If we reveal the second card, then we can reveal no more cards. So let's add in that property. Public bool can reveal, and then I'm gonna add get return second reveal equals null, because if that is null, that means we're still allowed to reveal a card. But once that is filled in, we can't reveal any more cards. I'm gonna also add in a method, public void card revealed, and then I'll say memory card, and I'm gonna say nothing for this method for now. We're gonna fill that code in later. So, now we need to add code to our memory card script. So let's go here. On mouse down, okay, so here are the rules of how we can reveal cards. Once a card is already revealed, it can't be revealed again, because that doesn't make sense. If the user has not yet revealed 2 cards, then we can still reveal cards. The rule is this: we cannot reveal a card that's already been revealed, and we cannot reveal any more cards if we've already revealed 2 cards. If you want to represent that in code, we can write something like this: card back.active self, which means, hey, is the card back already active? And controller.can reveal. So the rule is this: we are allowed to reveal a card that hasn't been revealed yet, and we can only reveal cards if we have not yet revealed 2 cards yet. If we revealed 0 cards, we can reveal cards. If you've revealed only 1 card, we can still reveal cards. So, if you want to reveal this card, what we need to make sure is we can reveal cards, and this card hasn't been revealed already. So I'm going to take that statement and shove it into an if statement. So, if the card hasn't been revealed yet, and we are allowed to reveal more cards, then reveal this card. Card back.set active false. And then controller.card revealed. And I'll pass in itself. Now, we also need a card that will we need also a method that will unreveal cards. So let's add that in. Public void unreveal, not update, unreveal. And I'm gonna say card back.set active true. So eventually we're gonna have some code that unreveals cards. But for now, let's see how well this works. Actually, no, not yet. We added a reveal card revealed method here. So what's this gonna do? It's actually going to keep track of the first and second card that we've revealed. Have we revealed a first card yet? Doesn't matter. What matters more is if we've revealed a second card. Actually, we need references to both cards because eventually, if they match, we're gonna compare their IDs, and they match if they share the same ID. And if they share the same ID, it means they have the same card fronts. So let's work on this method here. If first revealed equals null, it means we haven't revealed any cards yet. So this is going to be the first card that has been revealed. Well, so this card revealed is going to be given some parameter that is going to be one of our cards. So I'm just going to say first revealed equals card. So now we have our reference to the first card that's been revealed. Else, otherwise, if we reveal a card and it's not the first card, then it must be the second card. So we can just say second revealed equals card. And then I'm going to say, for now, debug.log. I'm going to say match. And it's going to return true or false, depending on whether the first and second card's IDs match. So first revealed dot ID double equals second revealed dot ID. So do they match or do they not match? Let's try it out. Let's run our game again. If I play it, we should see those rules in action. Because remember, we can only reveal cards if they've not been revealed. Okay, we can only reveal cards if we haven't revealed two cards yet. And a card can only be revealed if it hasn't been revealed yet. So those two conditions must apply. So it means if I click one card, and then I click another card, do they match? No, they did not match. Actually, some of the code's not working quite yet. So what I actually have to do is, well, make sure all of this code works still. Okay, so let me go in and debug this first. Okay, I found a bug in my code, and it is this. We can only set a card's back to be hidden under those two conditions. We haven't revealed it yet, and we're allowed to reveal more cards. So let's try this out. Hopefully this will work now. I'm gonna run this and then let's see how it works. It means I can only reveal two cards at a time. Null reference exception, object reference not set to an instance of an object. Let's see what the problem is. That is on line, 24 of memory card. A card by the active self and controller can reveal. Here's the problem. The scene controller and the cards must reference each other. So here, the scene controller, I have to drag and drop this onto the memory card. So the memory card script, the memory card needs a reference to the scene controller. The scene controller needs a reference to the original card. The scene controller needs a reference to populate the whole card, and the scene controller needs a reference to the original card so it can populate the whole grid full of cards, and the card needs a reference to the scene controller so it can talk to the scene controller. Hey, I've just been hidden, now what? Alright, let's try this again. I can reveal two cards at a time, and they do not match. However, there is no code in here so far, because what's happening is I can only reveal 2 cards at a time, and the game stops. This game sucks! So, let's add in code. So, once we have a match, we can proceed with revealing more cards. And if they do not match, then we can then proceed with hiding the cards and resetting things so the user can reveal more cards. So, let's look at that. Well, remember that the same controller also keeps track of the user's score, so I'm just gonna say private int score equals 0, and if the user successfully matches cards, then okay, let's just add in code like this. In our card revealed method, instead of saying debug.log did the cards match, I'm instead gonna add in the code for a coroutine. So I'm gonna say start coroutine, and then I'm gonna say check match. Now, there is no code for this coroutine yet, but that's what we're gonna add right after. So, I'm gonna add in the coroutine here. Code routine. Private enumerator check match. Why do we need a coroutine? Because we need time for the player to memorize what those two revealed cards are. So, what's going to happen is, once 2 cards are revealed that aren't matching, the game is going to leave them flipped up for some amount of time, and then it's going to flip them back down. So we can do that using a coroutine. So, if we want some time-based events, we can use a coroutine for that. So, time-based anything where the game needs to stop doing something, it has to stop for a while and do something after that, we can use a coroutine for that. So, if first, I'll just copy paste this. So if the IDs of the first and second card match, then we can flip. Then what we can do is we can increment our score, and then debug.log score. We can increment our score and then print that to the console. If the 2 cards did not match, stop the game for a little bit and let the player memorize what those cards are. After that amount of time, hide the cards again, and then no matter whether the cards matched or not, we need to reset first revealed and second revealed back to null, so that the player is allowed to reveal more cards after that. So I'm going to say yield return new. Wait for seconds. I'm going to say 0.5f. So wait half a second, then hide the cards again. First card unreveal. Second reveal dot unreveal. So these will hide the cards again and again. No matter whether we matched cards or not, we need to reset this so that the player can reveal more cards after that. First revealed equals null. Second revealed also equals null. And there we go. Let's try it out. I revealed 2 cards, they do not match. And there was this moment in time where I can see what cards they were, and then they were hidden again. I revealed 2 more cards, they do not match. But I know that this and this matched. Score equals 1 now. So I got some points for that. Reveal, reveal, no, reveal, reveal. Oh, they matched. Reveal, and I know there was a heart down here. And so that means by process of elimination, we reveal the cards, the game works. Okay, so we're almost there. What we need now is a means of displaying the score to the user. We could go about that using a UI object called we could go about that using UI elements. We can use something called text object using Text Mesh Pro, but there's another way. Let's go to 3D object text Mesh Pro. Let's add that. If we try to add that, it's gonna say you need to have TMP essentials for this. So let's just click that and import. This appears to be the first time you access Text Mesh Pro. So you're gonna have to import TMP essentials for that. Do you want to? You can also, if you want to, download this set of examples and extras. We don't really need that, but once we have that, we now have a giant thing of text here. So what we can just do is, if you look in the inspector, here's our text object. So it is a thing of text that is on our screen. If you look in the inspector, we have lots and lots of options for how we can format our text. All we gotta do is set this thing to a more reasonable font size of, say, 8. We're gonna select this and move the sizing handles like this, so it's like that. And then we can move this up here, so it's in the corner. Maybe we want it smaller than that, so maybe let's set it to size 6. That's good, right? Finally, we can just go into this text field here and type in okay. Yeah, there were a lot of text options in here, but all I really did was change the font size to something like 6. I need to also change this text to be score 0. And also, I just simply moved it to the upper left corner here. So now, all you gotta do is, we need the scene controller to know that this thing exists. We need the scene controller to know that it exists, so I'm going to add some code in here. I had already added in a private field for our score. All we gotta do is this. For us to use Text Mesh Pro in our code, we need to use another namespace called TM Pro. So using TM Pro, Text Mesh Pro was its own third-party thing, and then it was acquired by Unity. So that's why this is not the This is kind of not the de facto way of using text in games now. There was an old text system that's now being deprecated, or rather, it's now a legacy thing. It might be deprecated in the future. So we are now using Text Mesh Pro by default in our games, and it has been that way for the past few years now. So we have, using TM Pro, we are going to add a private field, serialized field, TMP underscore text. Score label is what it's called. So now, all we gotta do is, in the inspector, let's go to our scene controller object. If I click that, view it, now we have a little field for our score label. Drag and drop the text object into that field. So now let's add a little bit of code. So remember how we were using debug.log? We were just pushing this out to the debug screen. Instead of doing that, let's have it like this. Score label.text equals that. So now, instead of putting it to the debug screen, we are now updating the score text to reflect our current score. Let's try it out. Nope, no matches. Oh, we got a match. We got a match. Nope. Okay, I know this one was a square. So through process of elimination, there we go. This game works now. Okay, but once this is done, we would like to have the player start a new game. or maybe close the game. But let's focus on the start a new game part, because that's going to be more interesting. So, one of the last things that this project requires is for us to add in a restart button up here. So, that's actually our last unused sprite. So let's drag and drop that into here. There we go. Now, one thing to remember. If we want these sprites to respond to user clicking on it, if you want these sprites to respond to the user clicking on these things, remember, we need to have a box collider 2D attached to it. Okay. We're at the home stretch now, so we can just create a brand new C# script. Let's call it UI button. And all this button does is, if we click on it, we're gonna reset the game. So I'm just gonna open that script, and then I'm gonna add a few fields to it. So I'm gonna say serialized field game object target object, and then I'm gonna say serialized field string target message, and then I'm gonna say public color highlight color, and we can pick any out, and we can use any color we want. Let's just go with color.cyan. There we go. Is it capital C color? Yeah, it was. There we go. So now we have a few private fields we can use in our UI button script. And now we just have to add 4 different methods to this. First, it's the on mouse enter. So let's do that. On private void on mouse enter. And then the next one is on mouse exit. The next one after that is on mouse down. And the next one, the final one, is on mouse up. So, what's going on here? Well, it's more than just click on the button. We want to give feedback that the player is actually about to press the button. So, what is this saying? If we hover the mouse, if you hover the cursor over the button is going to change color. So, what I'm going to do is, in here, I'm going to say sprite render sprite equals get component sprite renderer, and that. And then I'm going to say if sprite does not equal null, then I'm going to say sprite dot color equals highlight color. So what does this mean? If we hover the mouse cursor over the button, then it's going to change color. That's a visual indicator that the user has moved the cursor over the button. And that's on mouse enter. Similarly, on mouse exit is, well, we changed the color of the sprite and we want to change it back to the color it was originally. So we're going to say the same thing, except the color is going to be color.white. Okay, on mouse down, that means the player has clicked on the buttons. Oh, the player has clicked on the button and we want the button to change again based on that thing happening. So if the player presses down on the mouse button and the cursor was on the button, we're gonna enlarge the button a little bit. So we're gonna say transform dot local scale equals vector 3 dot one times 1.1f. So basically we're scaling the whole button up just a little bit. And then on mouse up. Because now that button's going to be shrunken, it's going to be enlarged a little bit, so now we want to shrink it back down to its original size. So it's just going to say transform.localscale.vector. Okay, transform.localscale equals vector3.one. So now, instead of being enlarged by a factor of 1.1, it's going to be shrunken back down to its original size. We're then going to say, if target object does not equal null, we're going to send a message to target object. So what we're going to write is this following code. If target object does not equal null, then we're going to say target object dot send a message target message. Target object dot send message, and we're going to send the message target message. Okay. Now, let's go back to Unity again. We need to drag and drop the scene controller onto the target object field of our button here. So, our start button has nothing attached to it yet because we didn't even attach the UI button yet. So, let's fix that. I'm going to drag and drop that script onto the start button. So now, if we look at that in the inspector, we don't have it all yet. So that's because I forgot to save. So let's save that and wait for it to update. It should populate the whole thing with a whole bunch of fields. There we go. Okay, so our target object is going to be our scene controller. Drag and drop that from the hierarchy into this field here. Our target message, we're gonna get to that in a little bit. But if you want to change the color to be other than cyan, we can do it here. But let's just leave it at cyan for now. We can change it later. Let's type in the word restart into that target message field. And I've already added the box collider 2D, so if we haven't added that yet, we need to add it now. Okay, so let's go back to the scene controller. Scene controller script once more. We need to add another thing up here. So using, and that other thing is Unity engine dot scene management. So now we have almost everything here. What we need to add for the last thing is a restart method. So I'm going to say public void restart, like that. And then I'm going to type in scene manager dot load scene, and then I need to type in the name of the scene that we have been working with this whole time. Okay, so if we go up here in the hierarchy, it's going to say the name of our scene, which was sample scene. So let's just type that name in there. So, sample scene. So now, what should happen now is, if I press on the UI button, that's our restart button. If I press it, it's basically going to send a message to the scene controller. And it's going to say, hey, restart! And then the scene controller is going to call the restart method. That restart method is going to be called, and the scene manager is going to reload the entire scene again. Let's try it out. So if I do, okay, there, okay, those are revealed. There we go, and there. Game over, and I want to do a new game. So I click restart. You saw how that button grew a little bit and then shrank back down, but when I hover over it, it turned a little bit blue. That's because of our 4 events that we wrote in our UI button code. So let's do it again. Okay, then match. Try again. Nope. I know this was a heart. No, that wasn't it. Oh, okay, those match. And no, wait. Did I reveal these two yet? No. No, wait. Okay, so these are the hearts and these are the squares. There we go. And I can restart. Or I can possibly restart in the middle of a game. Okay, so every time I click on that start button, it's basically gonna reload the whole scene. So that's our way of restarting the game. There are a few technical points to be made in the textbook regarding how we are restarting the game, but that's basically one way you can restart the game. Basically, it boils down to a trade-off between efficiency of code and ease of readability to programmers, especially new programmers. But we can now say that our game is complete. Now, I added a small slide in here of, well, how we can build upon this game a little bit. So, one thing we can do is add new card types, and you've seen me already add new card types here. It's just that how we wrote the code for it is inconducive. It doesn't work well. It's inconducive to adding new code. No, it's inconducive to adding new cards. It doesn't work all that well. So we would have to, if we just added new cards right now, we'd have to change all these values, maybe change all these values, or we can do about it in a more smart way. We can just make these fields changeable in the inspector. So we can change all these fields in the inspector so they also can't be constant anymore. We can change those in the inspector so that the scene controller can auto-populate the grid. We can probably even make it even more smart by saying, hey, the spacing between the cards is going to be such and such units, so it's going to divide that space into 5. It's going to divide that space into 4 parts, and on those 4 parts, we're going to have 5 cards in between those parts, if that makes sense. Basically, it's going to be one way to make this even more robust, even more expandable, is just to basically throw a lot of code that we've written and have it to be auto-generating. So what I mean is, we would set the grid size in the inspector and have the scene controller calculate the spacing for us. We would then have this be automatically calculated for us also, so we don't have to hard code anything anymore. The scene controller will just take care of everything for us. So those are some technical things that we can do, or rather that we have to do, if we want to make this code easily usable for more additions to our game. Also, the concept of having the scene controller keep track of a score, we can use that idea for, remember our 3D game that we made a while ago? Well, it's currently in an infinite, how it was when we left that off was, it was stuck in an infinite loop. So you would destroy an enemy, a new one spawns. Destroy that enemy, a new one spawns. We can use the concepts in here for keeping track of the score, so that if the player ends up killing a set amount of enemies, then without dying himself, then we can call that a victory condition, and the player wins the game. Alright, that's gonna be it for this set of slides, and if you have any questions, definitely feel free to email me. I'll be having this video up if not by the night of this recording, then probably early tomorrow morning. Alright, so that's gonna be the video format for this, and our next game is going to be a platformer game. Alright, thank you class, and we'll come back for the next game, and then we'll see where to go from there. Alright, thank you.